Hi, I'm Dr. Robert Cohen. Today I'm going to talk to you about trigonometry definitions and identities that show up on the ACT. Now, this isn't all the trigonometry that shows up on the ACT, but these are all the trigonometric definitions and identities that show up on the ACT. The most basic trigonometry you need to know on the ACT is sine, cosine, and tangent. So let's start with those three. So sine, cosine, and tangent are used for a right triangle. So we'll have some angle theta, we'll say, in the triangle. And remember, in a right triangle, this is the hypotenuse. The side across from the right angle is the hypotenuse. Then if this is theta, we say this is the opposite side of theta because it's right across from it. This is opposite, this is the adjacent side to theta because it's right next to theta. Opposite, adjacent, hypotenuse. Now, we have three definitions here. Sine theta, okay, sine theta, cosine theta, and tangent theta. Okay? And sine theta, the best way to remember this is this thing called SOHCAHTOA. SOHCAHTOA. What this means is this is the definition of sine, this is the definition of cosine, and this is the definition of tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And the easiest way to remember these and keep them straight is to remember SOHCAHTOA. And whenever you have a trig problem on the ACT, just write out SOHCAHTOA. Take the 2 seconds to write it out in the corner. It will make everything more clear. You'll be less likely to make a mistake that way. Okay, so that's sine, cosine, and tangent. So, an example would be, let's say that we have this right triangle, and this is 30. Let's say, or we'll call this theta. And then let's say this is 1 and this is 2. Maybe, so what's sine of theta? Sine theta. Well, so opposite over hypotenuse. The opposite of theta is 1. And the hypotenuse is 2. So sine theta is 1 over 2, 1/2. Okay? You can do the same for cosine. You would need to know the adjacent angle and use that over hypotenuse. Basically, you're given some value of theta and asked to figure out theta. So a problem might say, what is the sine of 30 degrees? And you could either, do this. You could have these values memorized, the common ones. You could build a right triangle and figure it out. If this is 30, this is 90, this has to be 60. This is a 30, 60, 90 triangle. So if this is 1, this is 2, and this is 1 radical 3, which then, sorry, that was my cat, which then means that we can figure out sine of 30, because sine of 30, again, that's going to be, remember SOHCAHTOA, sine of 30 is opposite, sine is opposite over hypotenuse, opposite 30 is 1, hypotenuse is 2, this equals 1/2. Alternatively, you can just plug it into your calculator. Plug in sine of 30 degrees. And you have to make sure your calculator is in degrees and not radians. So, that's what a typical problem might look like. But instead of this, right, what if we saw this? Sine of some angle, we'll say x, equals 1/2. And now we need to figure out what x is, what the angle is. So there's a special way that we notate this. And what we do is we use, it's called the arc sign. So you say arc sine of x, or the way it's commonly notated and how it shows up typically on the ACT is sine to the -1 x, right? Sine to the -1. And in this case, what we're doing is, sorry, my cat is again being funny. What we're doing is you're switching the degree with the value of the function. So you say arc sine 1/2 equals x. And now you're going to get the degree. So again, you can solve this by doing the arc sine function in your calculator. And if your calculator's in degrees, you'll get the answer in degrees. Or you can build a triangle and, or remember the common values and see that sine of 1/2, that's going to be a 30, 60, 90 triangle. That's going to be 30-degree angle. So sine of 30 is 1/2. Arc sine of 1/2 is 30 degrees. So you just need to know about this notation. It's very straightforward. You're just flipping these two things. It's what you do when you want to find the angle. Whether you're dealing with sine, cosine, or tangent, it's the same for all of these. So again, if you have, let's say you have cosine of some angle equals 1/2, you can also write this again as arc cosine of 1/2 equals what angle? And the same with tangent. You could say arc tangent of 1/2 equals what angle? This would be the same again as tangent of the angle gives you this value. Now that we know about SOHCAHTOA, we need to know about we need to learn about a few definitions, a few identities. So there is this, for sine, cosine, and tangent, each of these you can flip them. You can basically take the reciprocal. So we say 1 over sine theta, 1 over cosine theta, 1 over tangent theta. And each of these has its own name. Okay? This, actually let me draw an equal sign. 1 over sine theta is equal to, this is called cosecant theta. 1 over cosine theta is called secant theta. And 1 over tangent theta is called cotangent theta. So if you see a problem and it says, cosecant theta equals what? You first want to say, well, cosecant theta is really just 1 over sine theta. And now all you need to do is figure out what sine theta is and plug it in to this expression. Sine squared theta plus cosine squared theta equals 1. So this is a major identity, and it might be manipulated on the test. What they'll often do is they'll often subtract either sine squared theta or cosine squared theta from both sides. So you could have sine, this could also, you could derive from this, you could get sine squared theta equals 1 minus cosine squared theta. Here we subtracted cosine from both sides. Or what if you subtract sine from both sides? Then you get cosine squared theta equals 1 minus sine squared theta. So you may see one of these on the test. You might also see they might take the square root of both sides. So you might see cosine theta equals the square root of 1 minus sine squared theta. So you might just see this on a problem, the square root of 1 minus sine squared theta. And that's the same as cosine theta. So you want to be on, anytime you see sine, cosine, and 1, and there's squaring or roots going on, automatically think about this formula and see if they are using or manipulating this formula, this identity, in some way. You have to plug in values and solve on with a sine squared or a cosine squared. Then the way you do it, it's really important just to keep this straight. Sine squared theta, this is the same as sine theta squared. So you're basically taking sine of theta and squaring it, multiplying it by sine of theta. Okay, so let's say you have, as an example, sine squared of 30 degrees, right? So this is saying, this is the same as sine of 30 times sine of 30. This is how you would solve this. And we know that the sine of 30 is 1/2. So 1/2 times 1/2 equals 1/4. So sine squared theta, if theta is 30, you plug in 30, this is how you solve, you get 1/4. All degree measurements, of course, so we want to remember that. I didn't note it, but that's what they are, a sine of 30 degrees, not radians. Okay, now, so this is different than sine theta squared. Sine theta squared means you're squaring the angle value. So again, let's say theta is 30. Sine of theta squared means sine of 30 squared. You plug in 30. Then you have to square 30, so you get sine of 900 degrees. That comes out to 0. So big difference between sine squared theta and sine theta squared. So when you plug in, if you have to plug in an angle value and actually solve, make sure that you keep track of this critical difference. Final identities you need to know on the ACT for trig are, you need to know what to do with a negative angle, basically. So cosine of negative theta, sine of negative theta, and tangent of negative theta. Cosine of negative theta, this is the same as cosine of theta. Actually, it means that it's an even function. If you remember even and odd functions. Sine and tangent, you take the negative out. So this becomes negative sine theta. And this becomes negative tangent theta. And these are odd functions. These are symmetric about the origin, and this is symmetric about the y-axis. You don't need to worry about this, but I just list this because if you remember, even in odd functions, this can help make this a little bit more intuitive. Maybe it'll also become more intuitive once you start looking at graphs of trigonometric functions, and at the unit circle. But for now, just remember these functions. If you have a negative theta, you pull it outside for sine and tangent, and you just get rid of it for cosine. If you found this video helpful, please like it, share it, or subscribe to my channel, which will help me reach more people looking for this type of information. Thanks.